In this video we will be discussing the difference between payout odds and actual odds, and when in fact there is a difference we refer to that as stacking the odds. Now this is a continuation on from example 4, I've called it example 5. When there is a differential between payout odds and actual odds, it's generally done so that the people or the organisations such as a casino or bookies who operate gambling games and things like that can ensure a profit in the long run. So the question reads, a simple game on Sideshow Alley at the Gympie Show is offering odds of 4 to 1 to correctly guess the outcome of rolling a 6-sided die. If 200 people bet $2 each on this game every hour, how much money could the operator of the game expect to make in 1 hour? Now the first thing I've done is I've written down with an asterisk the odds of guessing correct with regards to just rolling a dice. Okay, now this number 1 refers to, let's suggest I want to roll the number 3. Now there's one number 3 on that dice that could win, okay, as opposed to 5 other sides on that dice that could lose. Now if I express that ratio as a fraction with regards to the probability of winning or rolling the number in which you want to roll on that dice, the fraction or the probability is 1 out of 6. And I've also noted, but the payout odds are only 4 is to 1. Now that expressed as a fraction is 1 out of 5. So you have this differential, okay, with regards to the ratios and regards to the fractions. Now that differential, as I said, refers to people like bookies or a casino ensuring that in the long run they will make a profit from the game. So because there's a differential, there's going to be a profit made. And what the question's asking us to do is to determine, well, if this is the game, how much money would this person make should this much money be fed into the game in 1 hour? Okay, so essentially what we have is 200 people betting $2, which 200 lots of $2 is $400. So we're getting $400 every hour being spent in this game. So we want to find out how much of that $400 is actually going to be expected, or the bookie or the game show, the Sideshow Alley operator, the Sideshow Alley operator would expect to pocket at the end of that hour. So this is how we go about it. We've expressed these ratios as fractions, and I've simply done that by adding these two parts together to get 6 and the 1 potential winner, and likewise these two to get the 5 and the 1 potential winner. And I've noted the operator of the game gets to keep the difference of these values. Now the difference of these two values is not going to be a monetary amount. The difference between two fractions is just going to be a fraction. And there are no units associated with it, especially dollar signs. There's no dollar signs here at all. So these aren't monetary values. So we're just going to get the difference expressed as a fraction of the amount of money that was spent on that game in that hour. So we're going to get the difference once again expressed as a fraction. So we want to find the difference between these two fractions. Now to calculate the difference between those two fractions, what we need to do is subtract the smaller one from the bigger one. And you can do that in a calculator, or you can just do it as I've done here, where I've simply created a common denominator and I've used the common denominator of 30. So what I've done is I multiplied this denominator by 6 to get it to 30, and I've multiplied this denominator by 5 to get it to 30. What I've do to the bottom I must do to the top, so if I multiply this by 6 I must multiply that by 6, and likewise if I multiply this by 5 I must multiply that by 5. Which simplified, 6 times 1, or 1 times 6 I should say, is 6, and 1 times 5 is 5, 5 6s are 30, and 6 5s are 30. I've got my common denominator, 6 take 5 is 1, therefore 1/30th is the difference. Now that 1/30th as a fraction represents the fraction in which the operator of that particular venture on Sideshow Alley would expect to pocket at the end of a session. Okay, so let's move this down, and I've written that explicitly here meaning that the operator could expect to keep 1/30th of every bet made. And then in brackets I've specified, or you could think about it as they also get to keep 1/30th of the total amount of bets. Okay, so they're the same thing essentially. It's just easier to calculate this 1/30th of a total as opposed to calculating 1/30th of every single bet, then adding them together. So this is the one to go with. So we're just going to calculate 1/30th of the total amount of bets. So if we knew what the total amount of bets were, we'd simply calculate 1/30th of it, and we'd have the amount in which we'd expect that operator to pocket in 1 hour, which is what we are doing here. Now, all we're essentially stating is the amount in which is turned over, or the amount in which is spent on that game, on that dice rolling game, in 1 hour. And it's given in the question. It says 200 people bet $2, and I mentioned that earlier, that 2 lots of 200, or 200 lots of 2, I should say, is 400, meaning that in 1 hour, $400 goes through that particular game. Which means we simply need to calculate 1/30th of it, which is going to represent, as I said, the differential between the actual odds and the payout odds, and then we're calculating the value, or 1/30th of 400, which is done by simply multiplying the fraction by the value. Note of, and I will constantly use this in my videos, the word of in mathematics refers to multiply, and I use the example 3 lots of 2 is 6. 3 times 2 gives you 6, therefore of is times. It's just a little thing that I like to say to try to ensure that students see these things as being the same, because often in mathematics we'll see this word and won't recognise it for the operator in which it's suggesting. And if we do this calculation, we'll get our answer. Now, this particular operator will earn $13.33 or $13.33 in 1 hour, which, if you think about it, it's not a substantially big number, but to sit in a chair essentially and roll a dice and take people's money, I think $13.33 is not a bad number.